Hello students, welcome to Eshwari Thaniksha channel. In this video we are going to learn lens formula and magnification. So there are two formula. So we are going to learn this two formula and also very important table, sign convention table we are going to learn, and then we are going to solve two numericals, that is examples from the NCERT textbook 9.3 and 9.4 in this video. Students, if you are new to our channel, subscribe our channel and also share this video with your friends. So now let us start the video. So lens formula is given by 1 by V minus 1 by U is equal to 1 by F. So here V is called as image distance, U is called as object distance, and F is called as the focal length. Second formula is called as magnification formula. Small m is equal to, small m is nothing but magnification. Small m is equal to h dash divided by h is equal to V divided by U. What is h dash? H dash is called as the height of the image and h is called as the height of the object. So these are the two formulas we will be using to calculate the image distance, object distance, and also the magnification. So sign convention table is very important. So whenever you are calculating a numerical, you should know the sign. So whether U is positive, U is negative and V is positive or negative, you should know. Only then we can calculate the numerical. So here U is called as the object distance. So object distance for the concave lens as well as for the convex lens, it will be negative. So always it is negative. Object distance is always negative. And V is called as image distance. So image distance, it can be positive or it can be negative for the convex lens, and for the concave lens it is negative. So how you are going to find? So I'll show you how you are going to find the image distance. So now let us draw the principal axis. So this is the principal axis and let us draw the lens. So let us draw the lens. Now this is called as optical center. O is called as optical center. So image can be here or image can be on the other side of the lens. So here this is the lens. So image can be formed on this side of the lens or it can be formed on the other side of the lens. Always image distance should be measured from the optical center. So from here you will measure the distance up to here, or if the image is formed on the other side, you will always measure the distance from here to here. So if you are measuring the distance in this direction, so you know that incident ray, in which direction it will come? Incident ray will come in this direction, correct? So let me draw this in another color. So I'll draw this in yellow. So this is incident ray. Incident ray. So in which direction incident ray is coming? It is coming in this direction. So if you are measuring the distance in this direction, that is in the direction of the incident ray, then you have to take it as positive. So you will take this as positive. Positive distance if you are measuring in this direction. Suppose if you are measuring in the opposite direction to that of the incident ray. So incident ray opposite direction is this. So if you are measuring in the opposite direction, then it becomes negative. So you know that for the convex lens, image can be formed here or it can be formed here also. So if it is formed here, then you are going to measure the distance from the optical center to this in this direction. So if you are measuring the distance in this direction, it will be positive. If you are measuring in the opposite direction, then the image distance will be negative. So therefore here you can see V, it can be positive or it can be negative depending on where the image is formed. Whereas for the concave lens, it is always negative. Why? Because for the concave lens, always the image is formed on this side of the lens. Therefore, it is always negative. So next is focal length. So this is very important. So for the convex lens, this will be always positive. Make a note of this. And for concave lens, it will be always negative. And H is called as height of the object. Height of the object will be always positive for both convex lens as well as for the concave lens. And H dash is called as height of the image. Image height can be positive or negative for the convex lens, and for the concave lens it will be positive. So the meaning is, so here you can see this is the height of the image which is formed. So from where you are measuring, so you are measuring from the principal axis in the downward direction like this. So if you are measuring down, then it is negative. So if you are measuring above like this in the upward direction, then it will be positive. So this is the principal axis. If you are measuring up like this, it becomes positive. If you are measuring down like this, it becomes negative. So therefore, depending upon the image formed, so it can be positive or negative for the convex lens. And for the concave lens, it is always positive. Why? In the concave lens, you can see it is always formed like this. The image is formed in this direction. So therefore, you will be measuring upward like this, the height. So therefore, it is always positive. So this is the table which is very important, sign convention table. So make a note of this. We will be using in calculating the numerical. Next is M. So M is called as magnification. So if M value, if you are getting positive, meaning is the image formed will be virtual and erect. Suppose if M value is negative, then it is the image formed will be real and inverted. So these are important things. Make a note of it. So now we are going to use this in calculating the numerical. So let us take the numerical and let us see how to calculate. So now here what is given is a concave lens has a focal length of 15 centimeter. So for the concave lens, what is the sign for the focal length? Just check the table. Concave lens, focal length will be negative. So here I'll write F is equal to minus 15 centimeter. Then what else is given? At what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? So here the object, you have to calculate the object distance, and image distance is given here. Image distance is given as 10 centimeter. So image distance means it is V. V is equal to, so whether it is positive or negative for the concave lens. So see here, for the concave lens, V is always negative. So we will write minus 10 centimeter. So you have to calculate. And also find magnification produced. You should also find M. So now first let us use the lens formula. So lens formula already I have given here. So 1 by V minus 1 by U is equal to 1 by F. So write the formula, 1 by V minus 1 by U is equal to 1 by F. So now substitute the values. 1 by V is given as minus 10. Minus 1 by U is given as, you have to calculate. So this is equal to 1 by F is given as minus 15 centimeter. So now what we are going to do is, we are going to transfer this to the other side. So negative, if you are shifting to the other side, it will become positive. Same way this negative, when you are shifting to the other side, it will become positive. So 1 by minus 10 plus 1 by 15 is equal to 1 by U. So here this negative became positive when you shifted to the other side. Same way this negative became positive when you shifted to the other side. So now take LCM for this. For 10 and 15, take LCM. So for 10 and 15, 5 2s are 10, 5 3s are 15, 2 1s are 2, 3, 3 1s are 3. So multiply this 5 into 2 into 3. 5 2s are 10, 10 3s are 30. So LCM is 30. So I'll take here LCM as 30. So 10 3s are 30. So minus 3 plus 15 2s are 30 is equal to 1 by u. So you will be getting here minus 1 by 30 is equal to 1 by u. So therefore u is equal to minus 30 centimeter. So here 1 and 1 you leave. So in the denominator you have u. So take u is equal to 30 and sign will be there minus. So u is equal to minus 30 centimeter. So now we have found the first part u. Next we have to find magnification. So magnification is equal to, what is the formula for magnification? So check here the second formula what we have written. M is equal to h dash by h, which is equal to v by u. So let us write the formula. M is equal to v divided by u. So v, what is the value for v? Minus 10. Minus 10 and u we have calculated as minus 30. So minus and minus will get cancelled. 1 0 and 1 0 will get cancelled. So this is equal to plus 1 by 3. So m is equal to plus 1 by 3 is the magnification, or you can divide this further. 0.0. 3 3s are 9. So again here take one more 0. 3 3s are 9. And this will continue. So m is equal to plus 0.33. You can write this. So this is the magnification. So here there is a positive sign. So can you see here there is a positive sign. So if m value has positive sign, what does that indicate? So see here, if m has positive value, it means that the image formed is virtual and erect. So here you can write. So this means that virtual and erect image is formed. Virtual and erect image is formed. And magnification value is 0.33. That is, it is the size of 1/3 the size of the object. So meaning is object is big, image formed is small. So small image is formed 1/3 the size of the object. So object is this and image is this. So this is the meaning. So is that clear? So this is how we find u and m. Next we will take one more example, 9.4. So let us see what is given in the question. 2.0 centimeter tall object is placed perpendicular to the principal axis of convex lens of focal length 10 centimeter. So here object distance is given, h is equal to, so h will be always positive, so plus 2 centimeter, and then focal length for the convex lens is given. So what is the sign for the focal length for the convex lens? Check the table. For convex lens, the focal length will be positive. So I'll write here plus, so plus 10 centimeter. The distance of the object from the lens. So distance of the object is given as u will be always negative for both concave lens and convex lens. Find the nature, position and size of the image. So v you have to find, h dash you have to find. So let us first write the formula now. Let us use the lens formula now. 1 by v minus 1 by u is equal to 1 by f. So now 1 by v minus 1 by u is minus 15 is equal to 1 by f is plus 10. So now multiply this sign. Minus into minus will become plus. So 1 by v plus 1 by 15 is equal to 1 by 10. So now shift this plus 1 by 15 to the other side. So it will become minus 1 by 15. 1 by V is equal to 1 by 10 minus 1 by 15. So now take LCM for 10 and 15. LCM for 10 comma 15 is 30. So in the previous sum we calculated LCM is 30. So we will take that as 30. So this is equal to 30 is the LCM. So 10 threes are 30 minus 15 twos are 30. So 3 minus 2 you will be getting 1 by 30. So you will be getting here 1 by V is equal to 1 by 30. Therefore V is equal to plus 30 centimeter is the answer. So next what we have to find? We have to find H dash. So H dash, we have formula magnification is equal to H dash divided by H is equal to V by U. So now we will take only this much. H dash by H is equal to V by U. So H dash is equal to V by U into H. So now this H you take to the numerator. Now substitute the values. So how much you have V value? V is 30. So plus 30 divided by U value is minus 15. Minus 15 into H value. What is H value given? H is plus 2. Plus 2. So now here I can cancel this. 15 ones are 15. 15 twos are 30. So multiply this. 2 into 2 is 4. And we have here negative sign. Can you see here negative sign? So that negative sign you take it here. So H dash is equal to minus 4 centimeter is the answer. So we will write H dash is equal to minus 4 centimeter. So now what does this negative sign indicate? So in magnification, if H is there, so this is magnification formula. If negative sign is there, then it indicates it is the image is real and inverted. So you will write the image formed is real and inverted. So this is how we calculate. So students, if you have any other doubt, you can write in the comment section, and don't forget to subscribe our channel and share with your friends. So I'll meet you in the next video, students.